Welcome everybody. So we will speak about hybrid mesh, and we will tell about where we arrived from a naive microservice to a fully API gateway, and mainly the adoption we have done on a hybrid mesh ecosystem in the cloud. So first of all, who are we? So we are from ManoMano, and of course the tech team. So ManoMano is a marketplace. It's a European leader specialized in DIY, home improvement, and gardening. So I'm Aurélien, the head of architectures, core engineering, and infrastructures. And with me, I have my two mates, Bastien from the core team and Isaac from the SRE team. So what we have on the menu. So first, I will speak about domain-driven design, so how we have broken our monolith. After that, we will describe the API-first approach. So I will introduce you with our philosophy. Then Bastien will explain you how we implemented and speak about the adoption. And to conclude, Isaac will speak about the architecture. So we will do a global overview of our API routing, our infra on AWS, our Kong API flow. We will speak about the service mesh. And to conclude, we will speak about how we have extend Kong. So let's go to the domain-driven design. So how we have moved from monolith to API, and I insist to API. It's not from monolith to microservices. So for me, it's quite important. So let me explain you that. So first of all, domain-driven design is quite explained by Eric Evans. So you have the book, so you can read the manual. But I didn't recommend to read the blue one because it can be hard to read it and it's easy to sleep with it. So I recommend to use the red book named Implementing Domain-Driven Design. It's better to have something that you can directly use, and it's recommended by Eric Evans, so you can go it without any doubt. So, domain-driven design is mainly about cleaning the room. So we are here to untangle the mess and to identify bounding context. So if you are familiar with DDD, it's a classic pictures. So concretely, what does that mean? So first, you have to identify your domain. Then you have to identify bounding context. So the two potatoes on the pictures. Then define entities, aggregate, and services. Then the API, and at the end, the microservices. So if you start by designing microservices without any idea of the domain, there is no luck to find the right domain starting on the wrong way. So I recommend to focus on borders and interface in the domain. Avoid the easy stuff to work on the core of your domain because it's the easy part. The complicated part, it's the boundaries, the borders, the interface. Mainly on the monolith, it's where you will have mix some domain. So that's how we arrive on API first approach and our philosophy in ManoMano. So API is quite generic, and the first important thing is as a client you are calling an API, not a microservices. So you don't have to know the topology of the microservices. Then API is very generic. So we have started by defining some guidelines about everything we can imagine to have something coherent, to have coherency between all the teams. So about security, headers, data format, pagination, error, GDPR. So for example, you must secure all the endpoints with OAuth 2.0. The properties about that time should be suffixed with _at, these kind of things. And also the documentation is important for us. So now, time to jump in the implementation. So I think it's more important for you guys. So I leave the floor to Bastien.
Hello everyone, so I'm Bastien working on Aurélien's team and I'm very excited to be among you today. To give you a little bit of context, about 1 year ago we started to migrate the API from a backend monolith to the microservices, and we wanted to expose those API through an API gateway. So we decided to use Kong. The objective was to provide the developers the tooling and processes to expose those APIs publicly and internally. We had 3 requirements. So we decided to use Kong after a market study of the tool available, but we wanted also the processes to be easy to use. We wanted the processes to be straightforward for the developers, not to focus on how to expose the API, but rather on building them. And last but not least, we wanted to provide autonomy to the team with isolated processes. To achieve this goal, we create a kind of journey for the developers to publish their API on Kong. The journey will start with the local environment, where they would test to expose the API. Then they would create the configuration using deck, and they will publish the API using the application CI/CD until production deployment. If we start with the local test, what we did is we bring Kong to the developers. In other words, we create a full Kong ecosystem with Docker. This ecosystem includes Kong, obviously, but also Konga, which is an interface that can be used to handle and manage the Kong entities, but also the documentation for the developers to know how to create their entities and to manage them. Thus, we achieved to have a very quick adoption thanks to this sandbox, in fact, this playground. Obviously, this way of working was not the best solution to manage the routes on Kong. We did not want to use the interface to create the routes in production. So we decided to use Deck. Deck is the declarative configuration tool for Kong. It's a CLI tool that parse YAML file on commands, which you can use to synchronize your Kong database with the YAML file. In the other hand, you can also dump the configuration of the Kong database inside the YAML file. This tool is very useful because it's based upon YAML, which is quite well known among developers, but also it's very easy to integrate it in the CI/CD. So on our application folder, we decided to have in our guidelines, we decided to have one Kong service per microservices, so a one-to-one relation. The idea was to create one YAML file per environment and per policy exposure in the application folder. So for example, here for a microservice named MS example, on the state environment, which is a testing environment, we have one YAML file for the public endpoints and one YAML file for the default for the private endpoints. The next step would be to use the CI/CD to parse the YAML file and then execute the deck command to synchronize Kong. However, we wanted to follow one rule. We wanted a project to be only able to manage the entities that it owns. We did not want a microservice or any application to have side effect on the configuration on other microservices. Thankfully, Deck features a very useful parameter, which are tag. Tag provide a way to limit the scope of your command. So what we did is we defined a tag for every application. So for example, you see here for MS example, the tag is created on the GitLab project ID of the application and its name, so it's unique. And once we have tagged all the entities of the microservice, as you can see on the YAML file here, we are able during the pipeline to limit the scope of our deck command. So during our CI, the first job was to execute a custom validation script. The script would check that the tag was correctly defined, but also some rules we want to enforce. So, for example, the name of the files was well defined, or we have the monetary host for our routes, and then we execute the validation with deck of the YAML file. As you can see, we have limit the scope using the tag. And then for the deployment, it's only executing the deck sync command on every environment. Before giving the mic to Isaac, I would like to share two key figures. The first one is 50%, around 50%, which is the amount of microservices we migrate behind Kong. So we did approximately this in 1 year, so we are quite satisfied about it, and the migration is not over, far from it. And the second one, the 84%, is a satisfaction rate we had after an inquiry we made among our developers. 84% of the developers thought that the migration went well and was easy to achieve. So we can definitely say that our objective was achieved to have fully adoption of Kong among our team.
Okay, hello everyone, I'm Isaac, and now I'm going to share with you what was the implementation from the infrastructure point of view. So basically, first, we had the requirement for architecture team saying that we need to handle the following API routing, okay? And this is our network model for the API traffic. So we need to give answer for the traffic that comes from over internet, also for the traffic that are internally, okay? And we have two kinds of traffic internal. So we have the inter-API traffic that, as Aurélien mentioned, we are following the domain-driven design. So microservice that belongs to different domains will communicate internally through a specific API management system, okay? And also we have the inter-API traffic, where microservice that belongs to a specific domain will talk directly, okay, between them. So how is traduced this on infrastructure point of view? This is a simple architecture that we have nowadays on AWS. AWS is our cloud public provider, okay, that we are relying in our infrastructure, okay? And basically, we have two APIs Kong deployed, okay? We have an application layer with AWS auto-scaling groups, okay? And we have, for each of the scaling group, two different load balancers, one internally and one externally, to handle the external and the inter-traffic communication. On the database layer, we choose global Aurora database on Postgres, okay, where we have a replica in two regions, in the passive region, because our model, it's we have an active-passive architecture, okay, in order to handle a region disruption, okay. Also, we are doing every time backups, okay, of our Kong configurations that we are saving on S3, and we are replicating also in the passive region in case of disaster. So how is this traduced after the implementation? So this is the API flow putting in place Kong. So we choose Kong as a solution to handle this API traffic. Okay, as you can see, we handle the internet traffic through the specific Kong that is publicly exposed. Okay, and we can reach different kind of services. Okay, so we can reach services that needs to be exposed only externally. Okay, but also we have in the green Kong, we have another dedicated Kong for the inter traffic, okay, where we deploy all the private services and the private routes that we want to expose, okay, and we can reach And this allows us to microservice that belongs to different domains connect and talk between them. Okay, and also in the purple color, you can see the intra-domain APIs. So microservice that belongs to the same domain talks directly without any API gateway layer. So this infrastructure, this flow, as you can see, our service upstreams at the time we reach EC2 instances, also ECS applications, and also lambdas. Okay, we proxify all of those kinds of applications. But during this year, we had the need to evolve and go to Kubernetes. Okay, because at the time we were using ECS, our container orchestrator. Okay, because it was the easy way to start on AWS handling containers. Okay, but during this year we started the project to migrate to Kubernetes, and at the same time that we want to deliver the Kubernetes to the developers, to the company, we want to put also the service mesh functionality. Okay, so we want to encrypt all the data in transit from east to west. That is what we are doing with Consul. Okay, more specifically, we are using Consul Connect. Okay, because at the beginning we were using Consul, our key value store. Okay, and it was like a synergic election for us because we were comfortable with Consul, and we go to this solution. So we had a new challenge that it was to reach services through Kong that are deployed inside Kubernetes, inside the mesh. Okay, because at the beginning, as you can see in the purple line, we were reaching our service upstream. It was on EC2, on ECS, and also Lambda. Okay, so at the time it was working fine, but we had a new challenge. It was to reach new services that are deployed inside the mesh. So as you can see, the protocol is different. So we should reach this kind of applications. So how we implement this? So basically, what we build, it's a secure ingress proxy to the mesh. Okay, so we want to encrypt all the traffic, okay, that come from the north to the south, okay, using MTLS. Okay, as you know, Consul Connect relies on MTLS. Okay, the mutual authentication. Okay, where the core of this functionality behind the scenes is Envoy that is running. Okay, so the requirements for us in our Kong layer that we have is, in order to allow the communication with the services that are inside the mesh, is we integrated in our EC2 instances the Consul agent, the Consul Connect, and the Consul template. The more important thing is the Consul template, because one of the requirements where rely the authorization inside the services that are inside the mesh is the client certificate in order to guarantee the communication. So, and with Consul template, we are using to manage the whole life cycle of the certificate, of the client certificate that Kong is going to use to proxify the request to the services that are inside the mesh. Also, we are using the Consul agent to register the service, of course, okay, and Consul Connect to allow to the services that are inside the mesh call Kong through inside the mesh. Also, our requirement, it should be configured a valid DNS SRB resolution, okay, from the instance to reach any service that are deployed inside our service mesh, okay. Also, we will need to update the configuration in more specifically in the client SSL part in order to specify which certificates we are going to use to trust on that handshake. And also, we will modify the Kong services, okay, in order to reach these new applications that are deployed inside the mesh. Everything together has been monitored and observed with Datadog. Datadog is our monitoring tool in order to guarantee and validate that all this integration is working as expected, like that the certificate on Kong side is not expired or has been properly rolled out, and so on and so on. So from developer point of view, the only thing that has changed with the new services that has been deployed inside the Kubernetes, inside the service mesh, is two things. Basically, is the host. So the host, we are going to use now the service discovery endpoint that we register in console to reach directly the specific sidecar proxy that all application has inside the service mesh to reach Envoy. Okay, and also we specify the port that Envoy is exposing to receive these calls from Kong. So how looks like everything together? So we can see that how we have our hybrid integration when we can talk with the old legacy systems. So we can see the EC2 instances, ECS services, also the Lambda, but also we have a new component that appears during this year on our integration, that it's Kubernetes, okay, in the left hand side, okay, where we have all our applications deployed inside a specific namespaces, okay, based on the domain design, okay, and they can talk each other, okay, through Kong. So the last point that I would like to mention is that during this year, we have been continuous in a learning curve, okay, on Kong. And one of the things that we're starting to do is building custom plugins. Why? As you know, Kong has a very huge open source community where we can find a lot of open source plugins, but in some cases, we have some business needs that can be that don't allow us to take these open source plugins. But for this reason, we started to develop in Lua some specific plugins, okay, that covers these business logic needs. Okay, and here you can see a very highlight pipeline that we have in order to deploy a custom plugin on our Kong instances. The last, but not least point I would like to mention is that it seems that the Kong, we figured out that Kong can fill also another needs. Okay, so and we had a specific project, okay, where we were deploying static websites, client-side applications that relies on S3, and we use Kong, okay, to proxify static websites, okay. And why we did it? So basically because we have a lot of observability on Kong. Also, the logs on Kong is really good, and also one of the key things that we choose Kong to proxify in S3 is because we have some complexity in our CDN layer about, you know, the regex and request that we need to set up on the CDN to make these regex at the CDN level. So we remove this very complicated logic from there to rely on Kong at service entity level and roots entity level. So also, we get the benefit of this to implement an active passive failover on the CDN. So we have the CDN, and on root 53, we have a fallback mechanism in case that the CDN goes down, that we continue hitting the origin, that in this case is Kong. Okay. Also, the last thing that I would like to mention that we are doing, so we need to provide a custom environments for the developers for each branch. And in the pipeline, we are pushing on the flight specific configurations in Kongs to make it this work. And you can see, for example, a specific multi-branch endpoint, okay? And also what we have, for example, for the master branch. And that's it for my part. And I would like to pass the mic to my colleague, Aurélien, that he has the last word.
Okay, so thanks everyone. So 10 seconds left. So very few questions. Just did we try Kuma? Not yet. And as we like So I think this is the end. So if you have some question, put it on the chat.
We are not live anymore.
Yeah, but people can stay.
Okay.
Thank you very much for your attention and see you soon.
Thank you, guys. Have a nice day.
Yeah, see ya. Take care. Bye-bye.